Good morning students. In this video I am going to explain about the applications of magnetic materials. Mainly the main applications of magnetic materials are these magnetic materials are used as the data storage devices and also transformer core materials. Okay, first we will understand about the different types of materials. As we already know, the different types of magnetic materials are available. Those are diamagnetic, paramagnetic, and the ferromagnetic. And also depends upon the type of magnetism, how they are responding to the external field, and how much time they can retain that magnetism. These materials are categorized into the two types. Those are the soft materials and the hard magnetic materials. What are these soft magnetic materials? These magnetic materials easily gets magnetized and also easily gets demagnetized. We can easily remove the magnetism from the materials. When the external field is removed, they easily lost their magnetism, and they have initially high initial permeability, due to which they reach the saturation of the magnetization. So they initially having the high permeability, so they allows maximum lines of force through it. So due to that they easily gets magnetized, they can convert into the magnet. But after some time when we remove the external magnetic field, they easily lost their magnetism. Also depends upon the nature of those materials. So these type of materials susceptibility and permeability values are high. So these are the used in the alternating current applications. Next type of materials is the hard magnetic materials. In these hard magnetic materials, they will retain their magnetism and are difficult to demagnetize. They will take the so much time to get magnetized, and high strength field is required to get magnetized. When the external field is applied with high intensity and strength, then they will magnetize, and after the magnetization they will retain that magnetization. If you remove the external field also, it will take so much time uh, to remove this magnetism. So these are the materials are said to be the hard magnetic materials. So susceptibility and the permeability values are low. So what are the best applications of these materials, magnetic materials? Those are these materials are used in the transformer cores. We know that the transformer is made up of the primary inductive coil and the secondary inductive coil. So these magnetic core is piece of magnetic material usually made up of the ferromagnetic materials. Mainly the ferromagnetic materials are used due to which having the high permeability. The magnetic core confines increases the magnetic field and coil by a factor of several thousands. We know that the primary coil allows the current to pass through it. It will slowly changes as the magnet, and that flux induces into the secondary coil also due to the principle of the mutual induction. So here what will happen is the ferromagnetic material is used as the core material due to the having high permeability values. Here are some examples of the materials which are used as the transformer cores. These are all the magnetic materials examples. First one is the solid iron core. Here this is a block of pure iron, having the advantages high. It can retains the high magnetic field with having the features like hard magnetic materials without iron saturation, large eddy currents produced by the magnetic fields. It can retain the large eddy currents, and it can easily high magnetic fields. And applications are transformer operating at AC applications, because produced by the eddy currents produced heat and high frequencies. These type of materials are not recommended for the transformers which are operating at AC applications, because the large eddy currents produces the heat and it may damage the device. And next type of material is the carbonyl iron. Carbonyl iron is a high pure powder comprises of micrometer sized iron spheres coated with a thin insulating layer. It is a it's like a powder type of material which is coated with spheres coated with a thin insulating layer. Why the main advantage is provides the stability across the wide range of magnetic flux level and temperatures. The stability may be increased compared to the pure solid iron core, and they are efficient at high temperature and reduce the effect of. To eliminate the eddy current effect in the transformer cores, we can use this type of carbon iron cores. And next one is the amorphous steel, made of many layers of paper thin metallic tapes, reduces the flow of eddy currents and have fewer losses. Can be operated at high temperature. This is also another type of material used in the transformer cores, that is steel, made up of many layers of paper thin metallic tapes. So the next one is the silicon steel. Silicon steel cores also having high electrical resistivity and offers high saturation of flux density. It also has high permeability and low losses, mostly in low frequency transformer to flow through the narrow loops between every lamination layer. And next one is the amorphous metals. Amorphous are vitreous metals are glassy and non-crystalline. They have low conductivity to reduce the eddy losses, highly responsive to the magnetic fields. Advantages are high efficiency and high performance. Transformers efficient insulators to prevent eddy currents. And next, ferrite ceramics made from iron oxide and one or multiple metallic elements. Next, ceramic materials are produced in different specifications to meet diverse electrical requirements. These are having wide electrical requirements, and those cores are used in high frequency applications also. Next one is the laminated magnetic cores. These are used in the general domestic application. These are the different types of core materials which are used to this manufacturing of the transformer cores. Those are all silicon steel, amorphous metals, ferrite ceramics, laminated cores, and also carbonyl powder and pure solid iron core. These are all the different materials used in having specific applications and the advantages. And the next application of the magnetic materials is these magnetic materials can be used for the storage devices. The data storage can be possible using these magnetic devices. Example: magnetic tape, floppy disk, and hard disk drives. So these data can be stored in the form of magnetized data, and in which we can store the huge data in a less space, and the storage capacity is very high. Here we can use that how the data can be stored in the magnetic devices. We can see from here we can use a magnetic tape or floppy disk and hard disk drives to store the data. We will take a medium is used in the magnetic storage devices, which is coated with iron oxide. Here we can see that a disk is coated with iron oxide because which is a ferromagnet having strong magnetism, and this disk is coated with ferromagnet, where on which we can uh, on every space we can divide into the small regions. This disk is divided into the small regions, and we can do the magnetism. We can create magnetized portion and unmagnetized portion on this disk by creating south north and the north south. This storage of data and the reading of data can be done using these type of small magnets. Those are said to be the small moving magnets. Those are said to be the heads. This is said to be read head, small electromagnet, and this is said to be the write head. Write head stores the data on the disk, and read head retrieves the data from the disk. We will see how the write head stores the data on the disk. So for that, there are two types of magnetic polarities. We already know. Those are the two types of polarities are there: north south and the south north. Each one is used to represent either 0 or 1. Here 1 is represented, one polarity is used to represent 1, and one polarity is used to represent 0. This type of storage is also same as the storage of data in the computer, as in the digital form 0 and 1. Here we are storing the data in the form of magnetized portion and the demagnetized portion. Magnetized portion is considered as the 1, demagnetized portion is considered as the 0. Here the region where the data is to be stored is magnetized as 1. Here for example, north south is considered as the 1, south north is considered as a 0. North south is having the data, that is 1, read and write heads. The drive uses a motor to rotate the media at a high speed. Here the media is rotated at with high speed, and the data is written and the read using a small device called as the heads. Each can see a read write head moves very close to the magnetic surface. Here right head moves on the magnetic surface and it will creates the zeros and ones, means it will create the south north polarity and north south polarity, which is, yeah, as in the diagram, north south polarity is considered as the 1, south north polarity is considered as the 0. Same as the data is, uh, the digital data which is here, right data is transferred to the onto the disk in the form of 0 and 1s, and after that writing of the data signal is sent through the coil of wire which generates a magnetic flux at the gap. Here the data signal here the data signal is sent through the coil which the wire which generates the magnetic flux. Here the read head also moves on the disk and it will identify the zeros and ones present on the disk by the developing of the signal, and that will generate the magnetic flux around here. That signal is here. From the signal we can read the data which is stored on this disk. Okay, here only one thing we have to remember: the storage medium is coated with iron oxide which is ferromagnet, and the storage medium is divides into the small regions, magnetized portions and the unmagnetized portions. Magnetized portions or south north portions is considered as the north south portions is considered as the ones, south north portions is considered as the zeros, and the same data is transferred from right head to disk or medium, from zeros and ones. The data is stored in the form of zeros and ones. Here after that read head moves on the disk and it will captures the signals coming from the disk, and it will reads the data, and that is stored same as shown in the figure. So this is about the read head. Here we can see the read head is moved along the surface of the storage media. The information stored in a magnetic device, that is regions of magnetization and the demagnetizations are detected. So as I already told, when the read head is moving on the surface of the storage medium, it will identify the magnetized and the demagnetized portions. That is, it is identifying the zeros and ones, and the data is read by the read head by detecting the varying magnetic field across the gap. Here, the third application of the magnetic material is the optical recording. Here also the data can be stored using the using a medium, that is done using the laser. So this is said to be the magneto-optical recording. We will see the basic arrangement. Magnetic optical recording is a method of storing and retrieving the data using a laser. So laser and a magnet. Here we are taking the medium which can be magnetized. Here a thin film of magnetic material is taken. That magnetic film is coated with a substrate which data is written. Here a magnetic material is taken on which the data is to be stored and recording the data. Here we can see we are using the laser beam to store the data, and to read the data also we will use the laser beam. Here the disk is coated with film and initially uniformly magnetized. The total disk is, the storage medium is coated with uh, film which can be uniformly magnetized. The magnetic layer side faces towards the laser beam. Here the laser beam is incident on this storage medium from one side. The laser beam is used to demagnetize on a small spot on the film by heating it above a critical temperature. We know that the critical temperature, after a critical temperature, any magnetic material, whether it is ferro or para, it will demagnetize after a certain temperature, that is said to be the critical temperature. This laser beam, which will heat the storage medium at a particular spots, and it will demagnetize at that particular spots. Here we can see here reticular marks are there. These are all demagnetized portions where the data is stored in the form of zeros, and here these are all the magnetized portions. This is stored these are all considered as the ones. This is also considered as the ones. Here the laser beam is used to demagnetize a certain part on the storage medium by heating. By heating the particular part on this storage medium, it will go to the above critical temperature, and the it will automatically demagnetize itself, and the this total storage medium behaves like a magnetized portions and the demagnetized portions. Then what will happen, the data is transferred into the zeros and ones. Here we can see these points. A laser beam is used to demagnetize a small spot on the film by heating it above the critical temperature. So by disordering the magnetic domains. So a local magnetic field determines the direction in which the spot is magnetized when it cools. A relatively small weak magnetic field is applied to this region to modify its magnetism. The tiny region that is treated as 1 while unmagnetized region is treated as 0. Reading the data. Here to read the information also we will use the low power laser beam. That laser beam moves on the storage medium and it identifies the magnetized portions and demagnetized portions using the polarization effect. Due to the polarization effect and the direction of polarization, it will identify the stored data in the form of zeros and ones. Erasing the data. The data can be erased by magnetic field is applied in the opposite direction. If you apply the magnetic field in the opposite direction, then again the magnetized portions will become demagnetized. Then the data will be erased by heating above the Curie temperature. This is about magnetic storage using the laser and magnetic storage using the read head and write head. This is about the total magnetism lesson. The questions here we can discuss. Mainly here 1 or 2 marks questions are important in this situation. 1 or 2 marks questions and MCQs are MCQ point of view also we have to prepare for the exam. Here 1 or 2 marks questions we will see here. Magnetic dipole moment, we need to write the definition of dipole moment, field strength H, magnetization M, susceptibility psi, magnetic induction B, and permeability mu, and relative permeability mu r, and Bohr magnetism. These are all the definitions. For the 6 marks and 4 marks, they will ask 2-3 definitions at a time, and they will ask the relation between the M and psi, B and H, M, B and H also, and they will ask relation between mu and mu r and psi also. So you go through this material and read, practice all the relations also. 6 marks questions we can see here. Explain the origin of magnetism. Then we have to write about this orbital magnetic moment, spin magnetic moment of atom, and the nucleus magnetic moment, and explain how materials are classified on the basis of permeability. Then we have to write about dia, para, and ferro. Differentiate between paramagnetism, diamagnetism, and ferromagnetism. Same we have to write the differences between dia, para, and ferro. And fourth question, fifth question about the applications. About the magneto-optical recording devices means we have to explain about how we are going to store the data using laser. And next, the fifth question is explain the process of recording the retrieving magnetic storage. This is ordinary magnetic storage using read head and write head. And the fourth question is using laser. And the same questions will repeat 3 and 4 marks also. As single part, paramagnetic materials, explain about diamagnetic, ferro, ferromagnetism, and ferrimagnetism. Also, small definitions are there. These are all about the 3 and 4 marks. No numericals are there in this part. So read carefully about this material. We'll discuss in the next video about superconductivity. Thank you so much.